Hi there, my name is Breanna. I'm here at Concordia's Digital Fabrication Lab. This is a lab that we have under the unit of the Fine Arts here at Concordia University, and I'm going to show you around. So this lab started out a few years ago with just one technician. Our machines have been moved around the building, and when they became open to undergrads, graduate students, faculty, and visiting researchers, it just exploded. So now we are a team of 7 people. We are open 6 days a week. We are very popular. So this is our Z-Corp plaster printer. The way that this works is we actually have a bed of plaster inside the machine. It will roll out a new layer with this axis, layer by layer, as it prints each layer in color with CMYK coloring. So the ink catalyzes the plaster, solidifies it just a bit, and the plaster bed itself, which continues to sink, will hold all the undercuts and hold the piece in place until it's ready to be extruded. And as soon as we take it out of the plaster bed, we bring it over here to our cleaning station, where we have some air tools, we have a couple different brushes. We take all the excess plaster off, and then it gets recycled back into the machine and used for another print. So this is our Ultimaker 3, which is a dual head extrusion machine. We use a PVA and a PLA, and the PVA is a water-soluble material, so it will just go away with water. It deals with all of the undercuts with the print, and we use a one-colored extrusion of plastic for this machine. So this is our pop-it-in Pixa. Kind of like a microwave, we just throw it in, close the door, hit go. The way that it works is we have a base here that will turn 360 degrees and a laser that toggles on the side, and the laser will do either flat plane views of the object or it will do an entire spin of the object. It is limited in size, but it will get you a rudimentary scan of your object. This is our ET head Creaform scanner. The most popular scanner that we have in this facility. And the way that it works is it actually will use little stickers that we put on a black surface, and it will scan those stickers to create a constellation. Anything that's in that formula will be able to scan, so it will see the object that's in front of that or around that, and it will understand it and create also a higher resolution scan of that object, so we can get really fine detail of those objects. So this is our plastic form. The way that this works, it's a vacuum form. So we have an object which sits inside the table. We put a piece of plastic sort of sandwiched in between, and we have heating elements which will melt the plastic just to the point where it's malleable enough to go around the object. And as soon as it's ready, we will bring our object up, turn the vacuum on, and it will form around it, something like this. Okay, so this is, we did sort of a whale project where we made them on all of our different machines to show the differences. This was made with our Z-Corp printer, so we were able to actually take a photo of a whale and put it on the side of the object, which you can see with the ink. This is our resin printed whale. This one was printed with the clear resin, so it's a little bit of like a purple luminous color, mostly clear though. You can see the structure on the inside. Right here we have our extruded plastic whale. This one was made on our Ultimaker 3. And again, the geometric whale shape, all of the PVA material was washed off afterwards. This little guy was actually made on our laser cutter. So we used a program called Slicer for Fusion 360, and we're able to take the same scan, cut it up into a bunch of different pieces, and then print it on the laser cutter. So we actually store tons of our materials here. These are all the things that we allow on the laser cutter, which we find it's easier if we just provide it for the students. We cut mostly 1/8 inch ply, so we have 2 different sizes for that. And we also have all of our Trotec plexiglass in different colors and styles, which we sell to the students. So we are actually neighbors with this fabrication shop. This is where we make kind of maquettes. We have little areas for different types of fabrication, woodworking, metalworking, also a CNC router. But there's a little bit of everything in this shop, so it's good to come and finalize a project or figure it out because you have that ability to do so many things. This is our CNC router. Whatever depth that the laser cutter can't do, we generally have students come here where they can use larger drill bits to work into thicker pieces of wood. They can do things with different insteps and that have really nice quality with the actual bit working its way down. This is our bigger, heavier duty one. Okay, so the laser is our most popular tool here. It's used every single block. We have 3 blocks a day, 6 days a week. And it's used by a variety of different types of students, all of them mostly under the fine arts. So we have studio art students, we have design students, we have students making architectural models, printmakers constantly using it for woodcut, and then we have a couple other experimental types of artworks that are being made with this machine. But also we've become a little popular with some engineers who walk by, see our room, and kind of are interested in doing some perfectly fitted parts, so we get the odd other student in other faculties coming. But really it's for undergrads, master's students, the faculty, and our visiting artists and researchers. Before Concordia, I actually worked at a different university that didn't have a laser cutter, and it's just amazing to see how a lot of those processes that took so much time, that took so much finessing with fine tools and sanding, can be done so perfectly and so quickly with this machine. We do have full bookings all the time, but we also have a wait list that's always like 30 people long. The students just love it. As soon as they discovered our shop, it's like we can't go back now. The lineup is forever outside our door. So we're really trying to deal with that and optimizing the time, getting more people into this space so that we can have more students getting their projects done, and really figuring out how long their projects take, because they don't believe how fast they happen, if it's a 10-minute cut or maybe a 15-minute print. So we can fit a couple of them back to back as we optimize our process here at the lab. Trotec has really been a great company to work with. I mean, we have a lot of different machines here, so we're constantly having to call in external technicians to help deal with bigger issues. Because Montreal has such a base here with Trotec, and because they have such incredible technicians who come in, who are constantly giving us advice, who are constantly in communication with us when we have a problem, I mean, we don't have time to close down. We're too busy for that. So the service is really incredible. Thanks so much for visiting us here at the DigiFab at Concordia. If you want to know more about our program, about the school, about the things that you can do here at Concordia University, check us out at www.concordia.ca/fab.